All right, everyone, it's Mrs. Book here, and we're going to begin talking about Section 2.6 today. Section 2.6 in our book is actually a bit of a longer section. It has all to do with inequalities. So today specifically, we're going to talk about how to graph and solve an inequality. So go ahead and take out your notes packet that I passed out in class. It should look like what you see on the screen now. And I'm going to give you a minute to try the warm-up here on your own. It's something that should be familiar to you. Okay, that should be enough time for you. So let's see what you did here. So for number 2, negative 6 compared to negative 4. Negative 6 is actually less than negative 4 because it is further to the left on the number line. It is more negative. Number 3, negative 9 is greater than negative 10. It would actually be closer to 0 on the number line. Number 4 was rather interesting. Negative 11 equals negative 11. Number 5. Negative 27 is actually greater than negative 29 because it's less negative. And number 6, negative 38 is also greater than negative 39 for a similar reason. So the greater than and less than symbol are inequality symbols, and we're going to talk about a couple other inequality symbols here today. But let's refresh our brains on what an inequality is. And we defined this in our vocab chart back at the beginning of our unit. So let's go ahead and sort of paraphrase and rewrite this here. What is an inequality? Write this down with me. A comparison. A comparison. I'm trying to write here with my mouse, so that's the clicking that you might hear. Of 2 expressions. Comparison of 2 expressions. Okay. Now, once you have that written down, let's pause for a minute and talk about what the graph of an inequality would look like. We're not talking a standard XY plane graph here. We're talking about a graph on a number line or an inequality. So when we're graphing an inequality, that's our actual way of solving the inequality. We can't find a zigzag or anything like that. And as we move on, we're going to think about why that is. Why do we need a graph? But for now, let's write down the 3 things that you're going to see in the graph of an inequality. Here we go. I'm going to get a different color pen here. I'll go with blue. Number 1. There's going to be a dot. And that dot, which we're going to talk about more, is either going to be open, meaning that it's not colored in, or closed. And there will be a clear way of deciding that here that we'll get into in a moment. Open or closed. And the second thing, there's going to be some sort of shading that will need to be done, which again we'll discuss. And the third thing is there needs to be an arrow. And we're going to need that arrow to show that the graph continues on ever. So those are the 3 components that you're going to have in every graph of an inequality. So you should have those written down. And we're going to move on. So some symbols. We saw the first 2 symbols in our previous example. We know the one at the top that faces towards the left is the less than symbol. So fill that in for the translation, please. That's the less than. The next symbol in our box here is the greater than symbol. So you would read that as greater than. Okay. Now the bottom 2 look a little bit different than the ones we just spoke of. And maybe you've seen them before. Let's go ahead and get a spotlight on this. Okay? Notice that looks very similar to the less than symbol, but it has that line underneath. And then this one here looks very similar to the greater than symbol, but again has that line underneath. So they appear to be a fusion with equal symbol. A less than or equal to, or a greater than or equal to. And that's exactly what they are. So this first one is less than. Oh, let me go ahead and change my pen. That's the magic pen here on me. Sorry about that. It's going to end up disappearing. Yep, there it goes. Let's get the regular pen and we will try that again. That's the less than or equal to. So it falls into one of two categories. Less than or equal. And then likewise the one in the bottom row, so we should have our whole chart filled in at this point, would be the greater or more than. Greater than or equal. So that may or may not be a new symbol for you, but now we're on the same page, all on the same page here moving forward. We know that that adds the or equal to piece. Whenever you see that line underneath, you know it adds that equal component to it. Okay? So let's keep going on. So, for discussion, we say greater than or equal to. It falls into one of those two categories, okay? One or the other. So let's just write down that there's two possibilities. It's normally not both. It's just two possibilities. So we'll keep that short and sweet. And in terms of thinking about infinite, infinite means to go on forever, okay? And solutions to inequalities actually go on forever. So let's finish writing go on forever. Okay. And I'm going to put an example up for us to talk about. Okay. So let's suppose now we're involving some variables, some unknowns in our inequalities. So for example, x is less than 2. So if we're trying to solve for x, there are an infinite amount of possibilities that work here. Maybe you're already naming some in your head. One possibility would be the number 1, or 0, -1. -2, -3, -4, all of these work for the value of x. They're all less than 2. Even into decimals. How about 1.9? That's less than 2. We could go even further, 1.99. 1.9999. This is still very close to 2, but smaller. And we could continue in that fashion. So that's the reason for why inequalities with variables have an infinite amount of solutions. And that's why we need a graph to show them. And that's a huge difference between inequalities and equations. Equations have one definitive solution. Inequalities have infinitely many. And that's a big idea that we're going to continue to work with. Okay? So let's get to this dot on our graphs. So when you're making a graph, which will go on forever because it's going to have an arrow at the end of it, which we're going to see coming up, you need to include some sort of dot. And the dot is going to mean something. Okay, we wrote down on our other page that it's either going to be an open or a closed dot. So an open dot would mean that the number that it's comparing it to is a solution to the inequality. So write that down for now. And we say that that number is included. But an open dot, one that's not colored in, would mean that the number is not. Write that in all capitals for you. Is not a solution to the inequality. So we say that number is not included. So that would just mean you would draw a dot and not fill it in. Okay, so write that down for me, please, so you have it in your notes. Now there's a really clear-cut rule for knowing when to use these things. Closed dots will only be used when we have the equal to symbol with our inequality. Okay, so that's going to be these circumstances. And I want you to write these down. There's not exactly a spot for them, but I want you to write them down under here as I do. This would be with the less than or equal to, or the greater than or equal to. That's the only time you use the closed dot, because you are including the number that you're making the comparison to. Whereas for an open dot, it would only be for the symbols that you're already used to, the greater than or the less than. And I think this will make more sense when we look at a graph here coming up. But jot those things down that I just wrote down in blue on your paper so that you have them. Remember, if you're thinking of any questions as we're going through this, feel free to jot them down in the margins of your paper so you can ask me the next step. Okay, so I need you to turn your page. This is the last page we're going to talk about here in our video today. And this box, you might want to star it, put a circle around it, something, so that you realize this box is important. Okay? This box has steps that you can follow anytime you're asked to graph an inequality. It's very important. Okay? So these are the steps you're going to follow. So let's look at that. First thing is what we just mentioned. You're going to decide if there should be an open dot or a closed dot on the number line. I'll underline that by looking at the inequality symbol. Okay? So again, closed dot if there's the equal to line, open dot if there is not the equal to line. Okay? Now, the second step is to plot the dot on the critical number. So that's going to be whatever number appears in the expression. So if it was x less than 2, it would be the 2. Okay? Then step 3 we'll have to talk about as we're graphing, but for step 3, you're going to determine which direction you should shade by testing the values, and then actually do the shading. And at the end of that shading, the fourth step is you're going to need to make an arrow to show that that goes on forever, as we just mentioned. Inequalities have infinitely many solutions. So these are the 4 steps that you can always follow. All right, so let's try it. This is what you need to be able to do. So I have a number line, and it said, let's talk about graphing inequalities. And the number line that I have, we need to get it set up. X is less than 3 is the inequality we're trying to solve, which means we want to show graphically every solution for x, every value that is less than 3. So first of all, let's get our number line set up a little bit. We'll go -3, that'll be -2, -1, 0, 1, 2, 3. I'm just sort of trying to pick numbers near that 3, because this 3, that's the critical number that we talked about on the other page. I'll write that down. Okay, the critical number. So we need to put a dot on that critical number of 3, and we have to decide if it's going to be a closed dot or an open dot based on the inequality symbol. Well, it's just a less than sign. There is no equal to line underneath it, which means 3 is not going to be included in our solutions to this inequality. So we just draw an open circle like so on the 3. So go ahead and do that on your number line. So 3 not less than 3, so therefore it's not an answer. Okay, so we've got the dot. Next thing we need to do is decide which direction to shade. And we do that by thinking about what this means. So I'll write next to the word phrase. It means x is less than 3. Okay, x is less than 3. So we need to think about which direction or which side of the number line shows those numbers that are less than 3. Sorry, I forgot the word less. X is less, squeeze that in there, than 3. Well, that would be the numbers down here to the left. So all you're going to do, you're going to take your pencil and sort of darken, or you could use a different color if you'd like I am, and shade over your number line, connecting it to the 3, but not coloring in the 3. And then you'd also want to darken an arrow on the end to show that it goes on forever. And now that graph there that I have just shown shows all the solutions for x is less than 3. That's it. You're done. Okay, let's try one more together. Now notice this was very similar. I'll flip back to side 1 again. It's still x is less than 3, but now it's x is less than or equal to 3. So I'll set up my number line the same way that I did on the other page. Go ahead and do the same. I'm going to count by ones. Okay. And again, I have to start with this point of 3 here that's our critical point. And I have to decide, is that going to have a filled-in circle or a unfilled-in circle, an open or a closed circle? Well, because we have that equal to line, x can be less than or equal to 3, which means 3 is a solution. So we want to color it in. So if it is a solution, you want to color it in. So put a nice dark colored in dot on 3 like I just did. And once again, if we translate what this means, x is less than or equal to 3. So there's that or idea. It's either going to be 3 or it's going to be less than 3. So now I have to decide on my shading. Once again, the values that are less than 3 are to the left of it. So I'm going to go ahead and shade my number line, sort of darken it, shade over it, color it in, all the way down. And again, I want to put an arrow on the end. And you want to darken that arrow. You just don't want to leave the current arrow to show that it does, in fact, go on forever, that there are infinitely many solutions. They do not stop there. So those are the steps for graphing inequalities that have infinitely many solutions for the variable. We've done 2 examples. You have examples 3 and then 4. Okay? So what I would like for you to do now is use the examples that we just did. Okay? And I'd like for you to try these on your own, okay? And tomorrow, or whatever day we next have class, we will talk about these together. So this is your job. I'm going to write this real big to make it clear to everybody. I want you to finish these, okay? So write the graphs and the word phrases for numbers 3 and 4. They're very similar to the ones we just did, and we will check them in class. All right, guys. Thanks, and I will see you soon. Good job.